Hey guys, what's up? Spaslo here, and today we'll be going over an integration technique called partial fraction decomposition. Now I know it's kind of weird that we're going away from gaming, but I also want to educate y'all in this channel, so that's why I'm doing this. And this integration technique is actually quite difficult if you guys don't know the basics. There are actually 5 cases you have to remember just for one technique. So today and for the future, we're going to be going over all 5 techniques, all 5 cases for this one partial fraction decomposition. Now, partial fraction decomposition, just like in its name, is basically all about rational numbers, all about fractions, okay? So as we know, well, first of all, you have to know the basic integration. So if you don't know the basic integration, please do not watch this video because you won't understand a single thing. But if you do know and you are really struggling with this, then please continue watching this video, okay? So once again, this is for rational numbers only. So as we know, here we go. This is probably the most basic rational number right here. This is not the best, I wouldn't say this is the best example for this kind of technique because this is actually very simple. As you know, 1 over x is just basically the same thing as x negative 1 dx. And then it becomes, you add 1 and actually this becomes ln x because that's what it is, ln x. You actually will need to know this 1 over x dx because this is actually very important. That becomes ln x, okay? You'll see later why partial fraction decomposition uses a lot of ln, okay? So let's get actually a real rational number. Let's go x plus 1 over x squared plus 3x plus 2, something like that, dx. All right, how the hell do we integrate this? I have no idea. Maybe we can factor that out, okay? Maybe we can factor that out, which in this case you actually can, but pretend we cannot factor this out. What the heck do you do? That is what I'm about to tell you guys. So let's do this. So for case 1 is actually a very easy case, basically just an introduction to their basics. So case 1 is actually for when the factors of qx are not repeated. That's all you need to know. That is literally the only thing you need to know for case 1. When the factors of q of x are not repeated. Okay, so let's talk more about what the hell I'm talking about. There's just basically 4 steps you have to remember. Number 1, f is proper. So the function you're working with has to be proper. When I mean proper, I mean the degree on the numerator is smaller than the degree on the denominator. So for instance, going back to our example over here, right? The degree of the numerator is just 1. We look at the highest degree out of all the variables. This is degree 1. And look at the highest degree out of all the other variables. This is degree 2. That's very simple, right? And so then that you can work with partial fraction decomposition. And the next step is you have to factor the denominator completely, okay? Very important, you have to factor the denominator completely. In this occasion, you can factor it out and then you can scratch it out, so that's not a good example. But I will go over a good example right now. So let's go and talk about the next example here, in which I'm going to be showing you the integral of 2 over 2x squared plus 3x plus 1 dx. This is absolutely a perfect example for case number 1. Now, as we know, we got to check, is f proper? Yes, it is. Constant term, degree 0. Right, so I'm just going to say degree 0. Denominator, degree 2. Right, because of the exponent right here. So now that we know f is proper, we have to factor the denominator completely. All right, so we can use the cross method. Right, so the factors of the first coefficient, which is 2, 1, and the factors of the last coefficient, which is only 1, 1. In any case, we do diagonal, so this is why it's called the cross method, diagonal. 2 times 1, we multiply diagonally, and then the product that we get for both of them, we add them together, and we should get the number in the middle, in which case this one is. So this is the proper factorization of this polynomial. So 2 times 1 is 2, 1 times 1 is 1, so 2 plus 1 is going to be 3. So that means our complete factorization of this denominator is 2x plus 1, keeping the coefficients of each of them, and then x plus 1. Okay? I can go even further and say this function we can label as f of x. F of x is equal to some polynomial on top over some polynomial on the bottom, p of x over q of x, which means that this must equal to q of x. Okay? So if we're supposed to rewrite this entire thing, we can basically say, okay, 2 over 2x squared plus 3x plus 1 is basically just equal to 2 over 2x plus 1 and x plus 1. Okay. The next step we have to do, which is actually a little bit trickier, is actually use and apply the PFD theory. All right, so in this occasion, the PFD theory basically says that when you have this and the denominator factors are not equal to one another, they're not the same, they're not repeated, we can basically change this and give you this formula right here, where we have a over 2x plus 1 plus b over x plus 1, where a and b are just some constant that we don't know. Okay, so we can actually split them into two different terms, I would say, two different terms or two different fractions, right? And basically say a and b are just random constants that will add up together, in which it will make 2. Okay, so that's what this is. So that's why I say step number 3, do the PFD. Now when you do the PFD, the next thing after you do it like this, okay, now I'm going to tell you the reasoning. So the fact that f is proper means that the numerator degree must always be less than the denominator's degree. The denominator's degree is 1. So the numerator's degree must be 0, okay? In which case it's just a random constant, because a constant has a degree of 0. Same over here. Denominator degree is 1, must be 0 over here, okay? So first of all, apply constants. All right? I would say apply constants, and then the next step I would say is actually to multiply the entire equation by q of x. Okay, multiply the entire equation by q of x. So now we go down here, we check it out. If we multiply this entire equation by q of x, what we're going to get is this entire denominator is going to cancel, so we get they actually multiply together. Whoops. So they actually all multiply together, and that's what we get. Okay, so that was my mistake. I'm sorry about that. Now we're going to expand. Okay, so 2 is equal to ax plus a. Okay, so you distribute in, and then plus 2bx plus b. Okay, and what we're going to get is we're now going to put all these terms based on the variable that they have. So basically we're just doing another factorization in any occasion. So since both of these terms have x, we can basically put their coefficients together and say that they're all in terms of just x. And then we can put all the constants together, and we just say a plus b. So we have 2 is equal to a plus 2b times x plus a plus b. All right, so I'm going to go over here because I don't have enough space. So because we have that now, we can say that since this is equal to this entire term, we can basically say this entire Spliel coefficient is actually equal to 0 because there is no x term on the left side. This one is a constant term. This entire Spliel is actually equal to 2 because there actually is a constant on the left side. So we can basically just rewrite this as saying a plus 2b is equal to 0, and then a plus b is equal to 2. Very simple stuff, okay? A plus 2b is equal to 0, a plus b is equal to 2. And now we just try to solve for the constants. So since a is equal to 2 minus b, we substitute it back into the equation. We get 2 minus b plus 2b equals 0. So then this just comes out to be b. So b must equal negative. B must equal, let me think about this. B must equal 2, I think. Or no, it's positive b. So it's b must equal negative 2, okay? Okay, because there's a positive b right here. Okay, get rid of the negative. And then if we plug this back into this equation right here, we get a is equal to 4. Alright, perfect. So we now have a is equal to 4 and b is negative 2. Now we can just go back to this equation, just plug everything right back in. So I'm going to go up a page to over here. So basically we can say the integral of 2 over 2x squared plus 3x plus 1 is basically just equal to the integral of our a, which is 4 over 2x plus 1 plus negative 2 over x plus 1. And then we just do dx. That's simple now. Look at how simple it is. This entire thing actually comes into this thing, which is actually pretty cool. Now we can just integrate it properly. So we can split them into two different things, but it's very easy. This is just the coefficient, so it goes on in front, so we get 4. So since this goes in front, this becomes just 1 over 2x plus 1. 1 over anything on the denominator that is a degree of 1 becomes ln, right? Going back to this formula right here, remember that. 1 over x, which is just a degree of 1 in the denominator. 1 over anything on the denominator of a degree of 1 will equal to some sort of ln function. So ln is going to be absolute value of this entire thing, 2x plus 1. Now I have to be careful because this is 2x plus 1, there is a chain rule involved here. So because there is a chain rule involved, they're actually divided by 2. Okay? Because if we take the derivative of this thing, right? If we take derivative of this thing, you actually multiply by 2. So we take the integral, it's the backwards form of it. So we multiply by derivative, you'll divide it by integration. And last but not least, we have minus 2. Take the negative 2, the coefficient out, and we have ln absolute value of x plus 1 plus c. All right? And so then, to clean things up, 4 over 2 is 2, ln 2x plus 1, and then we get minus 2 ln x plus 1 plus c, where c is just any real number because c is just a random constant. So this thing, the derivative of this, the integral of this thing is just this thing. It looks scary, but that's actually what it is. So going back to our rules, first of all, figure out when f is proper. Make sure it is proper. Then we factor out denominator completely. Maybe I should add completely. There we go. And then we use the PFD. We apply the constants, which is just, in this case, a and b, because the numerator has to be a degree less than the degree of the denominator, so it has to be just a constant. And then we multiply equation by q of x, right? And then I can say we can just find the value of constants. Okay, then you find the value of constants, which is exactly what we did down here, right? We had two formulas, a plus 2b is equals 0, because over here we had this thing right here, a plus 2b x. There is no x value on the left side on the original function, so a plus 2b must equal 0. And over here, a plus b, there is a constant, which is 2. So we just have these two formulas right here. We're going to do some substitution stuff, and we get our two constants. And then we just basically add it back to this formula right here. So a is equal to 4, b is equal to negative 2, put it back on top, and then last but not least, the fourth step is we integrate. Integrate, and most of the time, we will use ln. You will get ln, okay? Ln of x in some way, okay? And as always, there it is. That's the integral, and that is case 1. Okay, you always have to remember to add c is an element of all real numbers because this is an indefinite integral. Okay, so that is basically case 1, all said and done. Once again, f is proper, factor denominator completely, apply the PFD, apply constants, multiply equation by q of x, find the value of constants, and last but not least, you just integrate. And most of the time, you're going to get some sort of ln x plus whatever is there inside the factor. So that's pretty much it. Thank you guys for watching. Like and subscribe if you love this video. And I just want to do something different. Just want to help out my math buddies. So once again, hope you enjoy. We're going to go over the next 4 cases in the future. So that's it for today. Thank you guys. And I'll see you next time. Bye guys.